Hello, everybody, and welcome to another Microsoft Reactor live stream. And today we are going to be finishing off or rounding out the series, Learn Go with Liam. Today is the fourth episode. Now, I apologize, I had to move this from December, but alas, we finally got here today. Now, I'm going to give it maybe a moment or two for people to join the live stream. So please do pop in the chat and tell me where you're from, where you're joining from, so whether it's the morning, afternoon, evening. Just let me know. And if you see me looking around, I've got multiple screens, and I apologize for the little reflection in my glasses. I've got a ring light as well. So please do. Chat's open. Pop it in there. Tell me where you're from. It's exciting to be here. Memory management is a big topic in a lot of different languages, and Go is absolutely no exception. It's, like I've said before, it's quite a juvenile language. We're still getting to grips with it, and adoption is still sort of getting there. So as we build up the eminence, as we're going through the series, we've kind of gone from a very basic fundamentals, moving into maybe a more intermediate topic, such as this one. And I'm excited to be doing this for you. So please do. Chat's open. If you're on YouTube, pop it in there. Obviously, if you're on LinkedIn or Twitter, because I know that's where I am streaming to as well, just pop it on there. I'll probably get to it probably after the session because I don't have that open with me, but we certainly do on YouTube. So if you head over to the Microsoft React YouTube channel, you will be able to see the live stream and you'll be able to pop it on in that chat. So like every stream and everything I do, we have a code of conduct. So please do take a second to quickly read this while we're still waiting for people to join. I notice we're sort of creeping up the numbers now, which is fantastic. Please take a moment to read this code of conduct, be kind, be respectful. And like I said, the chat is open for some fabulous questions. I'm excited for this one. So please just have a little read of this while we wait. And hello, Victor from Vancouver. Amazing. So we have people joining from Canada. It's great to see you. Well, not see you, but great to have you online with me. So what is the agenda today? What are we going to be going through? Now, it's pretty packed, and I'm not going to spend too long at the beginning just waiting this out because I don't want this to sort of take too long of our time. But I'm going to do a little bit of an about me. So who I am, where I came from, and what I do. We're going to look at a recap for the previous episode. Just a very quick, brief overview. Going to look at the introduction to the memory management system in Go. I'm going to look at what memory management is rather than in Go. We're then going to look at Go's memory model and how Go manages its own memory, or how you can manage it too without giving too much away. Then going to look at good and bad code examples. Okay, that's probably what you're all here for. You want to see how and what you do with it. So I'm going to jump through a couple of code examples. We're going to look at memory management in other languages as well. So in this stream, I'm going to be looking at, I think it's Rust, Python, and Java. Very brief overview. Not going to spend too long on them because this is Go. And I'm going to look at some top tips and a conclusion, and maybe a little surprise right at the end if we manage to squeeze in and if we have time. Fingers crossed that we do. So who am I? What do I do? So I am the Microsoft Regional Cloud Advocate for the UK. And I'm an Author Ambassador and a Dev Network Advisory Board member. What that really means is I like to speak at conferences, I like to learn things quickly, and I like to teach others as well. So what's the point in having the knowledge if you don't share it? So I stand on stage and I wave to people and I speak. And in the background, I do a lot of code writing as well. And I write in Go, absolutely, obviously. So 2 learning objectives that we have today, because again, like every stream I do, we have 2 learning objectives. And the first one is to understand the Go memory model at a very high level. I'm not expecting everybody to come out of this stream and be absolute experts in memory management or how Go manages its memory. And the second one is to understand how to manage the memory in Go. So one's understanding the model, and the other one is understanding how it manages it at a lower level. Again, not expecting you to know it all, just expecting you to have a brief overview and understanding of really what's going on under the hood when you write your code. Again, you can do this too. So if you're a student and you're watching this stream, please do sign up for a free student account. You get like a whole bunch of benefits. If you go to aka.ms/A4S, you can get your account there. And of course, if you're a professional, i.e. anyone who's not a student, then you can just go to azure.microsoft.com/free, grab yourself an Azure account. We're not using it in this stream, but it's maybe useful for follow-up ones that you want to do, or maybe some other episodes, which I show as well. So like I said, we are capping out the series here with episode 4. And if you've missed all the previous streams, I will pop in a link to the previous streams or the recordings that you can just go back and watch, or maybe my helper on stream might do that for me, but it's the Go series page, Learn Go with Liam. And yeah, you can go catch up, obviously, if you have missed the previous ones. So we've got a cloud skills challenge as well. So if you fancy doing a skills challenge and getting involved in learning a bit of Go, which is not from these streams, just a little bit more of a reading, more of like a steady, your own pace kind of thing, then please do go to aka.ms/Liam. Again, pop that one in the chat for you as well in a moment. Or you can scan this QR code and it will take you to the Cloud Skills Challenge. Now, if you complete it all and you want to get in contact with me afterwards, I can see if I can grab you some swag. I'm not going to tell you what it is, but I will try my best if you complete all 8 modules. That's a challenge. That's why it's called the Cloud Skills Challenge. So the recap. What was the recap? Or what did we do, sorry, in the previous stream? Data types. We looked at different data types in Go. So integers, booleans, strings, manipulations, and we also looked at data structures. Now, it was a whole stream dedicated to exactly that. So looking at maps, looking at structs, looking at, I think we looked at interfaces as well at some point. If not, then I will cover that again. I can't quite remember whether we did or not. But that was basically what we did in the last stream. So this is a bit more of a step up. Now, we learned how to write or sort of create a map and a struct and how you manage your sort of your variables at that or your sort of or your structures at that point. But what happens once you've done that? What happens underneath in the system? How is it managing that? And how can you be sure that it's doing a good job of it? You know, that you've not got leaks or maybe it's running out of memory or CPU usage is super high or something. So we're going to look at what happens underneath once you've done that. So let's look at an introduction to memory management. What is memory management? Well, it is basically keeping track of each memory location, regardless of whether it's allocated to a process or not. Okay, so it's your program understanding at a compute level if the memory has some values, if it's being used, or whether it is not. And it's essentially just figuring out which is which and if it can be used or if it can be freed up. Why is it important? Well, you need to know, or the computer system needs to know as well as you, whether you are going to be able to use that memory. So it can prevent memory leaks, it can prevent your program from crashing and continuously filling up the buffers, and it can slow down your system. All the things that you don't want, but you need to make sure it doesn't happen. And that's when writing good code, being sort of a good Samaritan when writing code comes into play. So it's one thing how the language sort out the memory management for you, and the other side is you understanding how to do it efficiently. Now, I've mentioned here as well on the slide that you want to avoid buffer overflows. Super, super low level. We don't really need to touch on buffer overflows at this point, but that could lead to security vulnerabilities. So it's all about thinking that, you know, what's going on in the background? Does this open something up for a bad actor or not? Okay, and believe it or not, having poor memory management is probably one of the sort of top bad actor influences when it comes to sort of infiltrations. There's so many different ways that you can get in through this kind of stuff. So having secure code is a very big part of it. So how did Go around what it does? What happens in memory management? So you got two things. You have a stack and a heap. Now, a stack stores your local variables and your function call frame. So when you first make your function call, that creates a frame, and then whatever happens inside that function happens within that frame. Okay, and a stack is last in, first out. So you may have come across this in the past. You may have come across round robin. You may have come first in, last out. But this one is last in, first out. So as you can see on the diagram on the right-hand side, if you have number 1 at the bottom, then number 2, number 3, and so forth, right the way up to 6. Now, when it comes to releasing that memory or sort of taking items off that stack, it's going to go from the very top one first. So 6, 5, 4, 3, 2, 1. Okay, so that's how it is allocated. That's how a stack is working. It's a fixed memory size. So you would typically see it, well, it depends how big it is, right? So if you think about a binary table, 1, 2, 4, 8, 16, etc., you may have stacks of frames. So an 8-bit byte or something, you'd have a stack or a memory of that size. And it is allocated at runtime. So in Go, it's compiled language. And likewise, at runtime, it then allocates the memory accordingly. And that's how you can have some panics occurring. That's how you can have some errors, some big stack traces, which I'm sure people are familiar with. So this is where it can you can run into difficulties. The good thing about stacks, though, is they are very fast and efficient. Okay, and as you can see, it's fast and efficient because it's small, it's agile, and it's just, you can just pop in, pop out straight away. But it's limited in size. So I'm going to let that sink in. That was quite a lot of information for a stack and trying to throw at you. And believe me, we've got so much more to go through. Next, we have the heap. Okay, so a heap is a little bit different to a stack. And this stores dynamic allocation of, this is a dynamically allocated memory location. Okay, so this grows and shrinks in the execution of a program. So it is dynamic. So a stack is fixed and this one is moving in and out, up and down. However, as you can see in the diagram on the right-hand side, a stack is more rigid and it's just, stacks of 2 pillars. And then the other side, you have a fluffy cloud. Now it represents the more agility that you have with a heap and how a stack's going to be one on top of the other. A heap could have one in the top left, one in the top right, in the middle. It kind of leans itself to that sort of visualization at this point. And with that, it becomes slower. It's much slower to access the memory locations in a heap and therefore less efficient for your program. But it has a much larger capacity. So they both have pros and cons and they're both used in different ways. Now, the best way to represent this and that I would, or the way that I look at this, is a stack is used for short-lived data and a heap is used for long-lived data. So something that you want to be around that you don't necessarily, you're not accessing all the time in your program could be in a heap, but something which is you're using and accessing frequently or want to mess with or play with, that would go on a stack. That's how I think of it personally. So how does Go manage its memory? What is the Go memory model? Okay, Go, some of you may have come across this before, but we have got a garbage collector. Okay, now what is a garbage collector? That is where it automatically runs around after the program. It's built in to Go, automatically runs around the program after execution, and it attempts to reclaim memory that is no longer needed. Okay, so memory that's not referenced anymore, it clears up. Just imagine a bin lorry going around town. It just goes up and clears all the rubbish that you don't need anymore, leaving you with everything in your house that you do need. Very, very similar concept, hence the word garbage collector. As I said, no need for you to manually do this. Okay, so this is one of the best things about Go and why people like it so much, because in other languages, you explicitly have to figure out your memory, understand what variables you're using, what addresses have what values, etc. Go does this automatically. So if you're using a value and then it frees up, it will clear the memory location. There are some caveats to that, but we'll get to that soon. And finally, it reduces the security and leak risks. Now, what I mean by this, and we'll probably get into this a little bit in a minute, but it stops it from having overhanging memory, which is going to be filling up and filling up and filling up and crashing your programs. And it stops bad actors being able to access this. We will circle back to that. Go also has Go routines and channels, which I have spoken about in previous episodes, or I've alluded to it, but we're going to talk a little bit more about them now and what they are. So a Go routine, what is it? Well, it's a lightweight execution thread and a function that executes concurrently with the rest of the program. So you've probably heard about concurrent programming in Go, and it's really fast and efficient. It's a lightweight thread in the program, essentially. That's what it is. They're extremely cheap to use, and they have really, really low overheads when compared to traditional threads. So if you think about something in Java, it is a lot different to what you'd have in Go. And the way that you would initialize that, you'd use Go and then call the function, or call the function name, or whatever you want to call it, the Go routine, and then you can do your execution. And I've got examples of this later on, and I will show you exactly what we do with the code. What is a channel? Well, a channel is a built-in feature, again, which coincides with Go routines, and it allows them to talk to each other. So it allows one Go routine and another Go routine, which are running parallel to each other. It allows them to communicate and transfer data. Okay, and they do that with something a term which is coined communication over channels. And it pretty much says, it does what it says on the tin at this point, right? Now, they prevent race conditions and locks and other synchronization issues that you can come across. I mean, I was absolutely dumbfounded when I started using them, having come from a JavaScript background and using async await and things like that. It was very, very hard for me to get my head around that. Go made this a lot simpler for me, and that's just my personal opinion, but it's a really good way that you can run parallel processes and have them communicate safely in a very safe manner. And of course, the syntax at the bottom here, we have got chan, which is a keyword in Go. We spoke about a few keywords before. And if you're writing to a channel, you need to have a letter, so the C, and then you'd have your arrow with spaces in between, and an X, or your variable, right? That is saying X is being written to channel C. And if you want to read from the channel, you do the channel at the end, so to the right-hand side, and you sort of point the arrow left. Really odd syntax, but you get used to it after a while. So what's the summary? So overall, Go's memory model is pretty, I'm not going to say simple, but it is on an overhead, it's pretty simple to understand. So it just makes sure that it doesn't run out of memory by using a garbage collector, and it allows the Go routines to communicate synchronously and safely. So therefore, it makes it perfect to write and run concurrent parallel code for cloud native environments. So it is beautiful. It is lightweight. You can run parallel programs, and you can have a very, very low overheads. Perfect for cloud computing, which is why it's dubbed one of the languages for networking and for cloud computing. So how do we manage that memory? How do we manage memory in Go? How can we personally do that? How can we help it understand itself and be safe whilst doing so? Well, there's two ways. And the first way is an odd way. It's using the new function. Now, this can be quite difficult to understand, and I'm going to try and break this down as easy as possible. Now, the new function used to allocate memory for a variable of a given type. So if we think about integers or strings or a Boolean or bool, whatever you want to call it, that is what they're used for, okay? It takes a type as an argument and returns a pointer. Now, we're going to talk about pointers again shortly, a little bit later, but that is then allocated a 0 value type. Now, don't worry if you don't quite understand what this means, but the example down here, we can see we've got PTR, standing for pointer, short for pointer. We're allocating that to new integer. Now, the little asterisk or the little star is then going to be sort of the value of a memory address of that pointer, which is 0. Okay, and it can be quite difficult to understand. I know it's kind of maybe quite deep, but this will make sense when we talk about pointers in a moment and when I show you an example. Now, the other way that we do this is by using a make function. Now, this is used to allocate data structures. So ones like slices and maps and channels. Okay, those are data structures in Go, and that's exactly what the make function's for. Okay, so it initializes the memory to use a default value, unlike the new function. So the new function provides a 0 value type at the end. This one creates a default value for you. So if you want to create a slice, you'd say make and then give it the slice data type. So in this instance here, we've got int, slice, and 3 and 5. So we're using it straight away. Whereas over here, we are not when we're using the new function. And again, when to use them, this is the rule of thumb that I go by. I use new to create variables and I want to initialize it later. So if I want to create something and then use it later on, that's fine. I use new. And if I want to use something straight away, so if I want to build a struct or a given type or something, I would use the make function, okay, and use it straight away. That's the rule of thumb that I go by. So let's talk a little bit about memory leaks. And we're going to move away from Go's memory management because that's quite intricate. It's really low level and it's quite hard to sort of put this down. So the further we go, hopefully, the more you'll understand. And I'm just going to, before we do this, I'm just going to check the chat and say hello to more people. So hello from London, Camille, hello. And who else do we have? Kingsley from Estonia, fantastic. And Bangalore. So we have got a truly global channel going here. Absolutely fantastic. Loving to see this. So let's jump back into what we're talking about. Memory leaks. What is a memory leak? Everybody has probably heard of them when we're coding, and some people may have been bitten by them before. And this is exactly where the security part of cleaning up your memory with garbage collectors and following it around and being very safe in that kind of context. This is where memory leaks and what memory leaks are. So what is it? It is when memory is being used or when memory is no longer needed, but is not freed up. So imagine you've got a program which is using up 100 megabytes of memory. And then at the end of that program closes, you're still using 100 megabytes of memory. It's not been cleared up. It's not been freed. There's scenarios that can happen, and that will then cause a memory leak. Other examples, I know you may have a recursive function or something. So actually, I have scenarios on the next part of the slide. So you have recursive functions, maybe with an infinite loop that creates an object and another releases it. Or maybe you have a global variable, which you assign a value, and then you never clear it. Again, you're filling up memory, and it is just getting filled and filled and filled and filled and filled and not cleared. Now, the if you're not clearing it, well, then what's going to happen? You're either going to run out of memory, or your program or system is going to crash. Now, admittedly, that could be quite difficult on a machine that has got a lot of RAM or a lot of power, but it's still possible. It's not impossible. So you've got to be really, really careful with memory leaks. So there's some tools in Go that we can use, and one of them is called pprof. And I'm going to show you this later if we have enough time. So I just want to make sure that we do. Yep, so we're 20 past now. Should have enough time to complete this and go on, show you what I want to show you and show you pprof. Now, it is a really cool tool, and it is very, very low level, and it allows you to see loads of things. Your whole stack trace, your whole heap, everything. Absolutely fantastic tool. And how can you help with memory leaks? Well, there's two ways. You can be vigilant, get the word out right, vigilant when using global variables. Again, I'm going to show you an example of what's good and what's bad. And you need to understand the code and how you're writing it. Okay. And there's another one called defer. Okay. Defer is a keyword in Go, and it is one of the most powerful keywords which I can probably use in coding, where especially when you're talking about files and sockets and database connections, it is extremely, extremely powerful. I've seen whole conference presentations all around the defer keyword and exactly how and when to use it and why. But that is basically memory leaks in a nutshell. Okay, we don't want them. There's ways to avoid them, and there's certainly ways to find out if you have one. So let's look at some code examples. Here's a good example of the defer keyword and exactly what I was just mentioning. So line number 1, we are going to open the file.txt file, okay? And we've assigned that to the file variable. Next, we're going to check for an error. Okay, we want to see if we can open that file. If it exists, wonderful, we'll open it. If it doesn't, then it's going to error out. Then you've got the defer. Defer right at the end. You're closing that file. Why would you not close it straight away once you've written something or once you've opened it? Or, why would you not do that immediately if you're written to it, you want to close it? You use defer keyword at this point. And this schedules the file.close to happen and be executed after the surrounding function. So you want that very first function to close before you close that file, okay? This ensures that the file is always closed, regardless of whether the first function completes or not. So if that first function errors, it will still execute this line of code, regardless if it errored or not. Okay, so it is really, really powerful when talking in context of files, closures, databases, connections, sockets, etc. And again, I kind of put an extra slide in there, but I didn't see it. The next one, garbage collector. Garbage collector is absolutely fantastic. How does it work? So in here, we have created a struct. Okay, we've called it my struct, and it has got data, and it's going to be of bytes. So it's going to be a byte slice. We're then initializing that, saying var my struct is my struct, and within that is going to have some sort of elements, and it's going to be of bytes, a byte slice. Then we're making it or giving it 100 megabytes of data. Okay, so we have given this struct, this byte slice, 100 megabytes of data of memory. Once that function is then closed, so once that func main is closed, the garbage collector will then release that 100 megabytes of data that has just been taken up and being used by my struct. Okay, so the garbage collector will follow and follow and follow on until it's not needed, and it will notice that it's not needed because it's going to be unreferenced. It will then just clean it and get rid of it, which is brilliant. That's how a garbage collector works. Now, I'm going to show you some bad examples, and I want to see if you can spot them. I've actually drawn the slide, so I don't know if you'll probably be able to get this, but if you're paying attention, slap it into the chat, and I want to see if you can get it. What is wrong with this slide? Or what is wrong with this bit of code? And I'm going to give you probably maybe like 5 seconds, 10 seconds, just to quickly put it in the chat and see if you can tell me why this is really bad. What's going to happen? I'm going to see if you can post anything. So if anybody posts something in the chat, let me know. And while I'm waiting for that, I will answer, is new allocating memory to stack or heap? Stack. It puts in the stack. I will actually circle back to that at the end, but I believe it's a stack that it points it to. Global var. Exactly. It is a global variable. what happens with global variables? Well, we've created this global variable. It is data, and it's got a byte slice assigned to it. We're then going to fill that byte slice with 100 megabytes of data or memory, or allocate it 100 megabytes of memory. But then at the end, we don't actually clear it. We're not clearing that data. It still stays dormant. So at the end of that function main, that variable is still going to be holding that 100 megabytes of memory, and it doesn't clear. So that could lead to leaks. That could lead to security vulnerabilities. And the way that we fix it is very much like using the previous example. We'd create a locally scoped variable in this point. So we just put the data inside the function and just scope it locally. That's all you need to do. Next one, unbound recursion. This is a bit of a tricky one and more of a, more of a trick question really, because recursive functions are really, really good in some contexts, really, really bad in others. This is a bad example of when it's not very good for you, or for the program, should we say. So in this one, we have got recursion, and we've got, 1 million recursive iterations over this function. What's going to happen if I leave that to do what it's doing? It's just going to go round and round and round and round and round and round and round until you've hit 1 million cycles. Okay, so it decreases the value of n every single time I hit the recursion loop. So in here, we're checking if n equals 0. After 1 million times, it will, but eventually. And then it's just going to iterate and iterate and iterate. How do we fix this? How do we make this better? Okay, this is a really bad example of when a recursive loop can create a lot of problems with memory. Because imagine if you're doing something in this recursive function, which is eating away at your memory and eating away at sizable chunks of your memory, each iteration that you go over. Well, you're going to eventually run out of memory, and your system's going to crash, or your program's going to crash, or it's going to panic, or it's going to do something you don't want. It's going to behave unexpectedly, is probably what you'd say. Well, we can fix that because you can bring the recursive loop down quite a substantial amount. So in here, instead of 1 million, we've got 1,000. Or you could just have a controlled iterative solution. So one which is maybe a while loop, maybe something which is a little bit more controlled from the user perspective. Okay, so that's when recursion is really bad and not good. Now let's look at some Go routines, because I know that everybody is going to be wanting some code. So over here, if I click on here, hopefully that's the wrong window. There we go. So Go routines, what happens with Go routines? Hopefully we can all see this. Let me just zoom in a little bit. So in this program, this is Go Playground, by the way, and I'm just going to move my microphone out of the way a little bit. So Go Playground is a really fun place to practice some Go programming. If you don't have it all installed locally, this is a really good way to sort of play with it. So in here, we've got a small program, and we got function main, and it's got 2 Go routines, task number 1 and Go routine task number 2. So as I said with my syntax earlier, you just initialize it, go, foo, open brackets function, right? And then we're going to wait for them to finish. Okay, you could use wait groups and whatnot with this, but again, if I can show you the bit with pprof later, then I'll show you how a wait group works. So what we're going to do is call task number 1 and task number 2. Now, with it being a Go routine, there's absolutely no guarantee that one will finish before the other. So there's no guarantee it's going to go 1 and then 2. It could go 2 and then 1, depending on how they execute, right? So if I click run, and down the bottom, you can see task number 2 and task number. If I zoom out a little bit, I want you to kind of see that happening when I click run. Oh, there we go. You can just about see task number 2 is at the bottom here. So if I click run maybe a couple of times, task number 1 is now at the top and task number 2 is underneath. That's the purpose of a Go routine, okay? They're asynchronous. They work, they don't run in parallel. It creates parallelism. That's just how they work, and that's a whole nother kettle of fish. But they coincide together. They allow you to run code synchronously, or asynchronously rather. Now, the next one that we have is, let's move over to channels. So how do channels work? Let me show you. Channels are fun because they allow different Go routines to talk to each other. Now, this is a really basic example of a channel, but hopefully you'll understand what I mean by it. So we're going to create a new channel, and we're going to do that by saying C is equal to, and then we're sort of assigning the variable and value at the same time. We're using the make function here. Now, remember when I said you got new and make? Well, now we're using make because we have got a struct. Well, it's not a structural, not a struct, but it's a structure of data. And we're going to pass in chan, and it's going to be of an integer. Okay, so I'm going to send a value to the channel. So we're going to have a go routine, and we're going to call it func. And in that function, we're going to write 42 to the channel. So remember when I said the syntax of writing is an arrow pointing left? That is this arrow. So we're writing 42 to the channel. And then all we can do is just pick off that channel, that data. So at any given point, I can read whatever data is on that channel. And I can do that by just print lining and then reading from the channel. Now imagine if you've got a different Go routine. Now a different Go routine would be able to read and do exactly the same thing. You'd be able to read from that channel. This is how they work. This is the purpose of them. So if I was to run this, we would expect to see 42 is the output. So we've got 42 there. So we written to a channel and we have read from a channel. Really simple basic example, but again, we can show some more later on. And after channels, we have got pointers and references. Now this is the fun bit. This is, I say fun, but it's actually quite tricky to understand. And it took me a pretty good time to understand this. So coming from JavaScript and Node, never really had to deal with pointers. A lot of C background programmers would have had to do it before. So depending on what your background is, it can either be quite understandable or pretty hard to understand. So let's have a little look at pointers and references. Again, I've got another small program, and this is going to illustrate what pointers are and how they work. Okay, so in here, we have got var pointer, and then we've got an asterisk and int. So the pointer is of memory of reference int. Okay, and if we print that out, if we print pointer, it's just going to say nil. So it just creates a nil value on that pointer. Okay, there's nothing assigned to it. There's nothing in that memory address for pointer. So let's go and put some values in. Let's go and build up a memory location. And let's see how this works. So in function main, I've got Liam's number. Now Liam's number is going to have the value of 27. It's going to be an integer. It's value 27, and I've assigned it to Liam's number. Really important to understand how this line here differs from this line here. So var pointer. So I'm now assigning a variable called pointer to the memory address of Liam's number. So it's a reference to the memory address, which is Liam's number allocated. Okay, so where that currently sits, I'm not looking at the value of that memory address. I'm just looking at the memory address of where Liam's number sits. So this first line, I'm going to print out the pointer. Okay, and I'm just going to, there's no references, there's nothing there, it's just pointer. So if I was to print out this number here, or this variable pointer, which is a reference to an actual memory address, what's it going to give me? It's going to give me the memory address. But if I use this reference, this asterisk of pointer, it's going to give me the actual value within the memory address. So asterisk pointer is saying, hey, I know you're assigned to Liam's number in that memory address with the ampersand. I want to know the actual value of what is held. And in this instance, it's going to be 27. So if I want to do some arithmetic and I want the reference point and the value from that location is equal to the value of that location plus 2, throw in the chat what you think it's going to come out with. Is it going to give me a memory address? Is it going to give me an integer number? This is pretty simple arithmetic, but I want to see if you can follow and understand the pointer referencing sort of intricacies here. This is probably the easiest way that I've managed to find or build up sort of an example for pointers and references, because it is actually a really difficult concept to understand and get to grips with. So there's lots of examples out there. I actually found a lot of them were really difficult to understand. So throw it in the chat, let me know what you think it is, and I will have a little browse through and see if there's any questions. Yes, exactly. The answer is going to be 29. Okay, so if we run this one and I click run, we'll see down here, we've got the actual memory location, which pointer is referencing. We have got the actual value of the memory location that the pointer is referenced to. And then we've got some pretty basic arithmetic saying that we can add numbers together. We can do sort of funky things with pointers and references. Okay, so the asterisk resolves the memory address to the data, and the ampersand just gets the memory address location for you, the actual memory address. That's the important part to probably take away from this example. And let me just quickly, before we jump into this one, I'm just going to skim through the chat and see if there's anything else that we have said that I've missed. Yes, global variables stick around. They do indeed. And they don't get cleared unless you sort of manipulate them and sort of do other things to them, okay? So you can overwrite global variables, but it's a little bit more tricky to clear them if you're just leaving them lying around and dormant, okay? So you can manually go in and play with them. You can manually clear them as well. So it's not completely automated from memory address or memory location clearings when it comes to global variables, but you can certainly accidentally leave them around, and then it's just a little bit of memory which is just being taken up by something which you might not realize because it's so small. And 9 times out of 10, it doesn't really affect small programs or sort of small production systems, but it's when you have ones which are big sort of chunks of memory which are lying around for a long time and building up over time every time you assign it and assign it and assign it, and it kind of builds and builds and builds and builds, and you kind of it crashes the system. Okay, so we've probably all seen maybe some pointer references, maybe you've got out of reference memory address locations, errors, things like that. That's all part of how this all fits together in terms of leaving memory that's lying around and dormant and not being cleared. So the garbage collector doesn't clear it if it's out of scope because it still thinks it's going to be used again. You've declared it as a global variable for a reason. Therefore, it's not going to go and swipe it for you. It's only going to be swiped if it's in scope. So at the end of a function, and it says, hey, this is scoped within the function, it can clear it at the end. That's kind of how that one works. Okay, one more question, and then we'll move on. Can you do pointer plus equals 2 in Go? Yes, it's just arithmetic. It's just as if the asterisk and pointer in that example would just equate to a number. So you certainly could. So you could do that. And yes, but I wanted to explain it, showing how each step works. It's just like you could do plus plus one or plus plus or something in other languages to add one. Very much the same in terms of that. And for everybody who is watching stream, this was the question. So let's move on to memory management in other languages. Now, this is where it gets fun. This is where I am not so well versed. So I will do my best at explaining this, and hopefully you all can follow along as well. So it's been really fun learning this. But let's jump into, if I turn this one off, I may have come out of, there we go. There we go, it's working. Let's look at Rust. Okay, Rust has a really interesting memory management system within its language. Now, I've chosen Rust because it's very popular. There's, I think, at least 3 or 4 people on my team which are learning Rust around the world and are doing very similar streams, but dedicated to Rust. Now, Rust uses an ownership and borrowing concept. Now, it's a bit of an awkward concept to understand, but it seems pretty okay on surface level. So every value that you assign has an owner, okay? And when that owner goes out of scope, the value that it owns will be dropped, which seems reasonable. And that prevents data races and undefined memory location behaviors. Okay, so it stops it from overhanging that function, and it will just drop it as a reference, and then you can go and clean it up. However, Rust has got this little nasty thing where it expects you to go and do that yourself. It doesn't do anything for you automatically. There's a lot of it, which is on the developer's shoulders. So let's look at this example on the screen here. Let's look at this function, okay? I am by no means a Rust writer. I don't really know the language very well, but this concept made pretty good sense to me. So the very first thing we're going to do is let s equal a string, and that string is going to be of hello. Okay, so created a variable, it's got a value. We then pass that reference of that variable to calculate length. Okay, so we've got s as a variable, and now we're passing that as a reference. So the ampersand, very similar concept actually to Go, passing that as a reference into calculate length. That is then going to borrow, not own it, it's going to borrow the variable s. Okay, so that variable s is now borrowed by calculate length function as a reference to that variable. It's then going to return the length. Okay, but this means that the variable s will still be accessible after the function call. So it's passed it back into here. It's still available. It's still got hello, but we've also used it and borrowed it down here. This means that it's going to give an output. And I'm sure if anybody saw the slide before I was zooming in, the output is going to be the length of hello is 5. So we're using this whole borrowing technique between the owner, which is this one here, this top line, and the borrower, which is calculate length. We're passing in a reference. So it's a very odd concept, but it makes sense when you look at it like this. So if you want to read more on Rust, go for it. I found this one pretty confusing to start with, but it's a really, really cool way to understand more at a high or more at a low level how memory management is working in terms of referencing and sort of how you sort of going through the system yourself. So post in the chat if you want more Rust stuff, and I can point you to some lovely Rust blogs and streams that are being done by my colleagues around the world. Next, we have Python. Now, I'm not going to go into any depth on Python. I don't really want to run out of time. In fact, we still have 20 minutes left. But Python uses a garbage collector, similar to Go. It will go around, it will follow you around, and it will clean up any memory which is unreferenced, okay? And it uses a technique called reference counting, okay? Now, that in your mind should already trigger something and say, hey, if it's a counter, does that mean that it has to do some sort of arithmetic? Does it need to sort of make pauses and search for stuff? You know, is it really as fluid as it could be? So it actually uses a cyclic garbage collector. Now, cyclic, circle, goes round, okay? So this is when it periodically checks for unreachable objects and frees them up, okay? So the best way to explain this or trying to understand this is there is a delay between a memory location becoming unreachable and its object in memory being freed up. Okay, so there's going to be a little time. Now, that can cause delays. It actually halts execution, tiny bit of time. There's going to be a delay. Okay, that can create memory leaks. That can create, so it can slow your program down if you're doing this quite a lot. But hey, it's an interesting concept that Python use. And it has its own little memory manager to allocate and deallocate memory for large objects. So arrays, lists, dictionaries, whatever you want to call them in Python. But yeah, again, if you want to take this one, go have a little read on reference counting. It's a really interesting concept to get to grips with. Like I said, I am not fully versed in it. It was just quite an interesting read when putting these slides together. And Java, of course, Java, a great language to be learning around and a great language to play with, especially now there's so much behind it. It's fantastic, but similar to Go, it actually uses a stack and a heap. Now, the garbage collector in Java is a built-in feature of the JVM, which is the Java virtual machine. So for those of you who don't really know Java, please do go and have a little read up of how that works. It's really, really interesting, really quite cool. But they actually use a mark and sweep technique. Okay, so it goes around on the heap and it finds stuff which is in the bubble, which is still referenced. It will mark it as referenced and it will then sweep everything else which is not and just clear everything that is not referenced at that point. Okay, it has a built-in memory manager which allows not just itself to clear the memory, but it gives you complete control over the memory management itself. So it's really, really cool and really interesting to get to grips with. So I'm not going to spend, like I said, I don't want to spend too much time on other languages. This is predominantly for Go. So what are some tips? What tips could I give you as a programmer to understand or help take you to the next level of memory management in Go? So tip number 1, use a default word. Okay, use it. It is really, really powerful and you can come in some really big issues if you don't use it properly. It should just be a default thing that you do whenever you open a file, do error check and just defer the closure to the end or the end of the execution of the function. Number 2, use the garbage collector wisely. Now, I say use it wisely because you need to understand what it actually does. Okay, you need to understand how it's used. You need to avoid creating and discharging lots of short-lived objects. This can cause your garbage collector to just overwork itself. And if, too much of something good can be bad. It can slow down the program at that point. You wouldn't want that. Okay, you don't want anything to block your thread or your execution of your program to, just to clear up memory, which you're just consistently churning through. You don't need that. You don't want that. So learn how to use the garbage collector and understand what it is actually for. And number 3, monitor your memory utilization. Just keep an eye on it. If you're using a program and you're really interested, if you think it's going slow and it should be fast, open up Activity Monitor on your Mac, or if you have a Windows machine, go into whatever you have on Windows to monitor what's going on with your memory, because that's the only way you can really tell. Use tools. I've personally used perf in the background. In previous years, I've used perf on Linux, which was able to scope out memory utilization, CPU utilization at a really low machine level. And it's interesting, but it's also super useful when it comes to having these small memory leaks, which then amount to being a big problem. Okay, because it's the small ones which are always the worst because they amount to something a little bit bigger every single time. So make use of built-in tools. Again, in Go, we've got pprof, and you can use external ones in Linux like perf. So brilliant chance to get to grips with some extra tech. So in conclusion, what is it? Memory management is super hard. Okay, it's really complicated. It's not an easy concept to get your head around, especially if you are new to programming or if you are just trying to figure out what actually happens when you declare a variable. Okay, because that variable isn't just going into thin air, it's being stored somewhere, but understanding how it's stored, why it's stored, and where it's stored is another matter. Again, garbage collector handles most of it for you if you're using a language that has one. Memory management is different across languages. Evidently, that's very evident, right? So Java is different to Go, Go is different to Rust, and Rust is different to Python. None of them are really the same. They may have similar attributes and similar references and methods of doing stuff, but they're ultimately very different. And memory leaks are super bad. Prevent memory leaks. Now, before you drop off, I've got a few things, maybe one thing that I want to show you, and it's going to be the pprof. So let's see if we can get this one working. Let's jump out of my slides, and I've just got windows everywhere now. So bear with me because I'm sharing the wrong screen. So let me remove this one from the StreamYard and add in another screen. Let's go for the main one. Okay, cool. So we have that one there. Let me just minimize everything, and you're going to see my lovely calendar and everything else on my stream and my lovely messy desktop. Let's go and have a look at this program that is written. Okay, this is a leaky function, and this is an example which I found and is super useful. And let me just zoom in a little bit so you can all see this here. No, don't launch any bicep stuff for me. I don't want any of that. So we're going to start at the very top. We've got imports, which are here. And there's one import in particular which we need to have a little look at. And it is this one. So of course, when you use a underscore, usually means ignore in Go. So it just means ignore it. So we've imported it. We've not necessarily given it a prior value. So I could put P there. I could put a letter, and I could then use it based off of that. But I've put an underscore. Then we've got a main function. Now this main function has got a Go routine, just called func, and it is going to listen and serve a web server for me on localhost 6060. Okay. I'm just going to print hello world. Now, usually you might do 8080 or 9090 or something like that. I've done 6060 because this is where pprof runs. Okay. Then I've got a wait group. Now, I said I was going to mention wait groups, and what wait groups actually do is they block execution, or they block certain parts of your program, and it allows Go routines to finish. It helps sync everything together at the end. So I have got a wait group, and I've got one Go routine in there, and I'm calling leaky function. And I'm just going to give the wait group into leaky function. So I'm just going to say wait, okay, block to allow the go routine to complete. So I call the leaky function, and this is taking a wait group, and it's going to defer. There's a keyword again, wait until it's done. And then I'm going to give S, and I'm going to give it a value of a string slice. So I'm giving it something, I'm giving it a variable. And then I'm going to iterate over this lovely loop, and a lot. I'm going to do a lot with it. Okay, it's going to take time. It's going to be very heavy, quite taxing on memory. Okay, so let's spin this up and see how pprof works. So if I go into this shell here, let's do that and do go run main.go, and this should probably print out hello world, which it does. And then on pprof, I can go over and do go tool pprof, and then localhost 6060 blah blah blah. Okay, now I can do top. Okay, so this is very much like curl at this point, but I'm now inside pprof, and this is allowing me to see everything on my system. So if I click enter, now very much like you do top in your terminal, you can see all the different processes and whatnot. Here we can see what's really going on with this function. So I can see that I've got main.leaky function is using quite a lot of memory, and it is, you know, at runtime, it's heavy, it's taxing. So this is a really good way to see what functions have got biggest ticks, biggest calls, number of calls, whatever you want to call it, and the sort of hardest bit on your program at that point. So there's another thing that we can do. We can actually go to that location. Let's open up a new Chrome window. And let's go into here. And that was not what I wanted to do. That was the wrong one. That downloaded a heap. Let me actually go to the URL. In here, we can actually see a visualization of what's going on. Now, you can sort of download PDFs or PNGs and whatnot through doing this. But this is a really interesting way for you to check out your allocations, to check out any go routines, your heap, your mutex profile, thread sent, all of these different things that you can see. So let's look at go routine. You can see every go routine that is being run and what's happening inside it and the stack trace. This is a really, really low level, interesting way to deep dive into what's going on your system. And again, you can look at the heap. So I spoke about stacks and heaps. You can actually look at the heap and what's in your heap, because it's there for longevity. It's there, that's consistently stuck with you. You can see in here that I can see, I don't know, whatever's going on with flate, deflate. These are probably all modules that have been brought in from the program. I can see here memory management, line 31. So whatever's going on line 31 down here is really heavy. And I would expect it to be, because it's inside a for loop, which is going around 7 zeros worth of times, right? So there's so much you can do with pprof, and it is an extremely powerful sort of tool that is built into the Go toolchain that allows you to do this. So that's just a really quick whistle-stop tour of pprof. Now, there's so much you can do. I could spend an entire stream just digging in and diving through all of this and showing you how to create a memory leak and how to then solve it and whatnot, but that's like an entire stream's worth of content. But for now, this is kind of where we're up to in terms of like an overview of Go memory management. So let's go back into the slides. And if I need to get them up again, so I'm going to tell you what's coming up next. So I'm just going to do this the other way and switch monitors whilst that's still there. So 1st of February, what's going on the 1st of February? That is next week. We've got a hybrid event at the Microsoft Reactor at 6 p.m. in person and online. So if you can't make it, if you're not in London, then you can watch online. But if you are, come on down, come say hello, and come and see us there. We are being taken over by NVIDIA. So we've got some amazing talks all on I'm going to say them, not quite the metaverse, but in terms of high compute, GPUs, those kind of things. So if you're into gaming, into understanding how that sort of high level AI models are run and trained, really awesome. We got some cool talks. I am going to be running another series. So on top of this one, I am going to be running, so after this one rather, I'm going to be running the Go Show. And we are hoping to start that very soon. Now, the sooner the better. Now, what I'm going to be doing is I'm going to be going through maybe things like Stack Overflow. I'm going to be going through Reddit forums, and I'm going to be finding questions and pieces of code, and we're going to be solving it together. So it'll be 30 minutes of just pure code, going through the problem, understanding what it is and how to fix it. Also going to throw in some interview questions, because people are asking lots of different questions now in interviews around Go and how you solve different problems. And we're going to walk through some together. I mean, I might not even know the answer, but I'm certainly going to learn with you. So that'll be half an hour, and it's going to be a bi-weekly stream. So I'm going to do it every other week, and just going to be full of all the Go goodness. And of course, on the 23rd of March, I am actually running a Microsoft Tech Days with somebody in the community, which is going to be a 3-hour stream where we are going to be building an end-to-end system using Go and Microsoft Azure. And how you can do it too. It's going to be a code along with us, and we're going to show you, and we're going to take you through a whole bunch of cool things that we're going to be doing to build this front end, a server, and a database, and how it all works together using just Go. So that's going to be a really, really cool thing. And yes, I will be posting the links to all of this in the chat in just a moment, because I've still got a couple of minutes. Go through this one. One more thing, which I would really, 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 really appreciate, is if you could scan this QR code or go to aka.ms/Liam feedback, and 5 really short questions. It's literally like a tick box, I think, and there's one that you have to write in, but you don't have to write much at all. It's like a 1 or 2 word based on your topics that you want to learn from. So I will just pop that into the chat now. So go to ak.ms/Liam feedback, and that should take you to, let me say, like that one. And that will just give you a chance to give me some feedback. I would really appreciate it, based on how I've done, how this series has been, and what would you like to see coming from you, because the only way that I can help you is by you helping me. I would love to just randomly point out lots of different topics and things that I'm really interested in. But of course, the whole purpose of this is so that you can learn and skill up with me and help better everything that we're doing together, and sort of have a community learning environment. So please do give me some feedback, give me some ideas, and I will see what I can do, and hopefully pump out some really great content for you going forward. And this thing has decided it doesn't want to work on me anymore. There we go. And of course, let's connect. So thank you very much. And I would really appreciate it if you do the feedback form. And of course, the Cloud Skills Challenge here, if you really want to get hands-on with Go and learn a little bit more around what we're doing at Microsoft, how we're helping the Go community, and what's really going on in terms of what we're doing here in Microsoft Reactor. So I'm going to punch a whole bunch of links into the channel now, where you can all have a little bit of a gander. So let me hide that one. So if you want to sign up for Tech Days, this is the link that you will need. So this is going to be the 23rd of March. So if you really want to just watch us for 3 hours, have a little bit of a bash, myself and somebody else from the community, we're going to be filming it from a TV studio in Thames Valley Park, which is Microsoft HQ in the UK. And of course, it's going to be virtual, so you can watch from wherever you are in the world, and it will be recorded, and it will be streamed on Reactor YouTube as well as Microsoft Developer YouTube. If you want to get a little bit more hands-on with pprof, here is a really, really cool article and blog, which I found really useful and was actually one of the examples that I used today. Absolutely brilliant. And if you would like to catch up on any of the previous streams that I've done on Learn Go with Liam, then you can catch them there with the series page. And I think that is actually all the links that I needed to post today. In fact, there was one more. It was the Cloud Skills Challenge, which was aka.ms/Liam. On there is a Cloud Skills Challenge, but I would just really appreciate it if you could do the feedback form. So do we have any questions? And I'm going to check LinkedIn as well and see if there's anything on LinkedIn, because my phone has been silenced. Going to give you maybe a moment or two to put anything in. Nope. That isn't how that is to stream up then. If there's no more questions, please do reach out on socials. If you have any questions, please do just get in touch. Any questions around Go, any questions around DevOps, I'll be super excited to hear from you. And I'd just like to say thank you very much for sticking around, and thanks for joining me on Learn Go with Liam series. It's been a fantastic journey. Have a good evening or the rest of your day, wherever you are in the world. Thank you very much.